All right, welcome back. So we're going to move on to problem number 4 here. It says write a function for the sinusoid shown. Now keep in mind when they use the word sinusoid, it doesn't mean it's necessarily a sine function. It could be sine or cosine. Okay, sinusoid just refers to sine or cosine. So just keep in mind the vocabulary. Okay, so for me to determine whether or not I should use a sine or a cosine for this graph, I look at x is equal 0, and I see where the y value is. Notice that x is equal to 0, the y value is at its max. And there's another graph that we studied, right? It's basically our cosine function. Actually, if we just go up here, right, the cosine function, in this case we use t is equal to 0, same thing. It starts at its max, right? And so using the cosine function would probably be the easiest way to do this problem. Now, towards the end, I will show you, I don't know if it's that much more difficult, but a different way of writing this equation using the sine function. Because remember, sine and cosine, you can use the same, you can use two different ways to express a function, whether sine or cosine, depending on the phase shift. Okay, so we'll talk about that towards the end. All right, so we established we're going to use the cosine function. And I'm just going to write the general equation over here. Now, notice I didn't use a phase shift because if you pick the easiest function to write this equation, you don't need a phase shift, okay? I'll show you again towards the end. If you use the sine function, you will need to use the phase shift. Okay, so just like the previous problem, right, you need to figure out what the A is, what the B is, what the K is, right? The previous problem, the jump rope problem, was in the context of a word problem. But this one, they just give you a graph, and you just need to calculate all these individual values. Okay, so let's start with our amplitude over here. It's just 1/2. And you need to calculate what these coordinates are. So it looks like this coordinate right here is going to be 0, 13. This coordinate right here looks like it's pi over 4, 13. And this coordinate down here looks like it's the midpoint between pi over 4 and 0. So that, I would probably say it's pi over 8. And it looks like it goes down to -5. Okay. So, all right, our amplitude is 1/2 max minus min. So 1/2 13 minus -5. We're going to get 18 over 2, which is 9. So there's your amplitude. And your midline, right, is 1/2 max plus your min. So 13 plus -5. You're going to get a midline of 4, which is your K value, right? You can even see from the graph, I kind of already drew this in here, that this looks like it's the middle of this graph. Okay, so the very last thing you need to calculate is your B. And your B is really determined by your period. And so your period, right, if you remember the formula, is 2 pi over B. This time we don't really need the frequency. I kind of just made a mistake over here. Don't really need to use that. All right, so to calculate the period, right, it's the horizontal length of one cycle. And if I were to ask you, hey, what's the period? The distance between here and here, right, before the graph starts repeating again, is simply pi over 4 minus 0. Okay, so the period, I'll write it up here, is pi over 4 minus 0, which is just pi over 4. Okay, so you can kind of cross multiply over here and solve. You're going to get b pi is equal to 8 pi. These pi's are going to cancel out, and you're just going to end up with b is equal to 8. Okay, so you have b, you have k, you have a. You can plug it in. Now make sure there is no reflection across the x-axis, right? If this had started at the minimum, right, in which case then you'll need a reflection across the x-axis. A would have to be negative, okay? But because it starts at the positive amplitude or it starts at the max, we don't need that. Unlike this previous problem, right? Because at t is equal to 0, it starts at the minimum, then of course we need a reflection across the x. Okay, so our final answer would just be f of x is equal to 9 cosine of 8x or b is 8x plus 4. Okay, so this is just, just FYI, right? I showed you the easiest way to do this problem. And not to overly complicate things, but remember, I just wanted to show you that you can write sine and cosine. You can write any graph in terms of sine and cosine, right? And so, remember, your sine is just a phase shift from your cosine. So if I were to say, hey, write this equation using sine, well, let's take a look. What does the sine graph look like? The sine graph looks something like this. Right? In this case, f of x would equal sine of something, something. Okay? Now, we don't want the graph to look like this, right? We want the graph of the equation to be this. But remember, this equation's in terms of sine right now, right? And so the way we make this graph look like this, right? If you kind of take a look, we just need to take this portion of the graph and shift it all the way over here, right? Take this guy and shift it. And if we shift it, if you can visualize, right, this would be over here, this guy right here would be over here, and then this would be over here, which is what we want. Okay, so if I say, hey, for a bonus, bonus question or extra credits, like write this equation in terms of sine. Well, what you would do is you would say, hey, f of x is equal to 9 sine of 8. And then over here, I'm going to have a phase shift, but because I'm moving it to the left, right, I need to write a plus. Run out of space here. Plus what? Right? I mean, this is exactly the sine function, but I want it to look like this. I have to shift it over. And whatever this distance is, well, if you remember the way I showed you how to graph sine, cosine, and tangent, or actually just sine and cosine, we calculate the width of the interval, right? This is just your WI. And so the way you calculate the WIs, right, you take your period of this graph and you chop it up into fourths, right? So WI is my period, which we calculated as pi over 4, right? And then chop it up into fourths, which is pi over 16. And so this is the shift of the graph I want this to be if I were to write this in terms of sine. So f of x is equal to 9 sine of 8x plus pi over 16 plus 4. Okay, so, hopefully this is not overly confusing. If you were to go to Desmos.com, graph this, and graph this, you will see that those two graphs coincide, okay? And again, the key is to figure out, the width of the interval by taking this period, chop it up into fourths, and that's how much you need to shift this by to get this graph using the sine function, okay? But in the beginning of the lecture, right, I said the cosine is probably the easiest way to do this problem because at x is equal to 0, it starts at the amplitude or the max.